Okay. Can you confirm that my slide is shared to you?
Yes.
Yes. Thank you. Okay, so let us start. Hoping that your friends will join in the middle or sometimes. So till now, if we can recall that whatever we have discussed in this class. So in a briefly, we have discussed almost everything related to the fundamental of the IC engine. Okay. And then we have discussed about the fueling system, uh, combustions. So such topics we have already touched. And now one of the another important topic that is related with engine exhaust emissions we are going to discuss. We have given a lot of our attention or focused that how to improve the engine performance. Yeah, in terms of the power output, in terms of the improving the fuel consumptions or reducing the fuel consumptions, regarding the various technology. But everything is really very important, whatever we have discussed, but the emissions is equally important. In spite of your car or your bike or your automobile or vehicle is having very good power output, power consumption, everything looks, it's really very good. Even maybe you can say it's less costly also. But if the emissions is not going to be satisfied by your vehicle, then you cannot drive on the road. Or you can say you cannot launch that car in the market commercially. So that much important is the emissions. We have discussed during the beginning of our semester that when we were discussing about the fuel air mixtures and how to calculate the stoichiometric mixtures, we discussed at that time the very simple reaction where the hydrocarbon is reacting with the oxidizer and it is giving carbon dioxide, water and nitrogen if the oxidizer is air. And then we did some kind of calculation and then find it out that this is the exhaust going to be exhaust composition and this is the air fuel stoichiometric mixtures or all sort of the things we did it. But in realistic, even at that time, we discussed that it is not so simple that hydrocarbon is reacts with oxidizer and it gives only the carbon dioxide and the water and nitrogen. There are several other components or several species associated with your exhaust, and that is species is well proved now that is harmless for the human health as well as for the environment. And therefore, and these things in it was realized probably you may say in the 80s by the all over the world that we cannot ignore the emission or we cannot ignore the water the species is coming out from the exhaust. And then several countries try to take it seriously and then they try to put the limitation that any vehicle should not emit this much of a species more than that this limit. And that is called emission legislation. So, and then they try in, and that was also it may consider as the birth for the newer technology in the IC engine. Because to satisfy the emission norms, you have to play with the combustion, we have to play with the exhaust after treatment technology, and there's so many other things, and that requires the technology. And therefore, there are several other so many things has come out. So in India as also, we may say in the late 90s, yes, the government was putting some kind of legislation, and then officially from 2000 onwards, there was a emission regulations that our emissions regulations were put on the automotive company that your vehicle should not emit this much of this particular species. And then slowly it becomes tightened over the time. But you must realize that reducing the emission is not the only the responsibility of the automotive manufacturer. It is the responsibility also falls on the shoulder of government, particularly in India, because government of India is responsible to supply the fuel. Okay, they controls the fuel, and reducing the emission is not the one way that we can play only with the technology and the control system and to optimize the emission, but it also equally important the quality of the fuel, that how much fuel, what is the purity level of the fuel. Okay, so therefore the government cannot put legislations in one go and then it can say that now we are going to have almost clean like emissions. So it's responsibility of the automotive manufacturer to fulfill these criteria, because for fulfilling that criteria, government has to also supply the fuels up to the standards. For that, they need to upgrade the refineries, invest so much money in the refineries. So therefore, from 2000 onwards, slowly the emission norms are were going to be tightened over the time, and now we have a 2022 and we are almost closer to the emissions regulations of European countries. California emission norms is considered as the one of the toughest emissions regulation all over the world. But as far as the European emission standards is concerned, we are almost probably, we can say, one step behind them. Even though we started our emissions regulations much later than the European countries. European countries, they try to put some kind of the legislations from the late 80s, but we started the everything in from 2000 onwards. So in the span of the 2022 years, the development, particularly in the automotive technology, has been tremendous. And then because of that, we are in very good condition. And the emissions is very closer to the European emission standards. So that is the history that we are going to discuss in this class. Now, as far as the emissions is concerned, your exhaust emissions is concerned, we may divide into the different categories. Like for gaseous emission, particulate emission, that is the solid emission, regulated emission, unregulated emission. What is the gaseous emissions, particulate gaseous emissions? So obviously the from exhaust, engine exhaust contains the species in the form of the gaseous and some of the species in the solid particle also. Accordingly, it can be divided into the gaseous emissions like SC, NOx, CO, CO2, whatever. And then particulate emission, that is soot or particulate, that we are going to differentiate between the difference between the soot and particulate, that is considered as the solid particles. Now, regulated emission and unregulated emission. As far as the general knowledge is concerned, you may also know that CO, CO2, SC, NOx, PM, particulate matter. These are the species coming out from the engine exhaust. Okay, but it is not like that even. There are so many other species also available in the engine exhaust. Okay, so what happens that there, since the engine exhaust contains a lot of species. Okay, so what comments to that they selected some of the major is pollutants that is coming out from the exhaust. Okay, and then some of the species um, are very less in the amount or very less in quantity. So, and also their effectiveness on the human health or of the environment is completely different. So the regulated emissions comes. So what is the regulated emission? The government of the country puts some kind of the legislation on the specific species that their emissions or they cannot emit more than certain limit. So the such kind of the species on which we have put the legislation is called regulated emissions. Okay, it means we are regulating that species. And apart from that, whatever the species are coming out, that we termed it as unregulated emissions. So the gaseous emissions, particulate emissions, regulated emissions, unregulated emissions. What are the regulated emissions we have? We have total unburnt hydrocarbon, that is called THC. Sometimes we call it SC also. So, but we call it total hydrocarbon. Whatever the unburnt hydrocarbon coming out in the exhaust, irrespective of their forms, individual forms, like whether it is alkane, alkene, or alkyne, or hydrocarbon aromatics, we are considering as a total. And then one of them is total unburnt hydrocarbon. CO, carbon monoxide, NOx, oxides of nitrogen. NOx is the mixture of NO plus NO2. Okay, and the combinedly it is called NOx, NO plus NO2. CO2 particulate matter, that is PM. Now here we have very interesting things that CO2, as far as the India is concerned, CO2 is still not falls under the category of a regulated emission. It falls under the category of unregulated emissions. And so therefore, in India, we have only 4 regulated emissions: THC, carbon monoxide, NOx, and particulate matter. Particulate matter we'll discuss later on, but here again there are two branches with respect to the particulate matter. One is the mass basis, that how much mass it is coming out, and then the second thing is the number wise, how many numbers per cc of the particulate matter is emitting. So here again we have a two branch that need to be just satisfied in terms of the mass and in terms of the number density. Other three pollutants, THC, CO, NOx, all these things, there is a gravimetric limitations that this much gram per kilowatt hour or per kilometer. So that is the limit. So only what I'm trying to specify here, that CO2 in India is still not falls under the category of regulated emissions. However, in some of the countries like European or US, it is falls under the category of CO2 emissions. Okay, CO2 emissions. Can you imagine? You are burning the hydrocarbon, and we are trying to maximize the efficiency of combustion. It means we want that all the carbons in the hydrocarbon converted into the CO2. And now you are putting the limitations on the CO2. That is need to be think that how it is going to be. What are the way that without compromising the combustion efficiency? Okay, and we can achieve the CO2. But anyway, so unregulated emissions, apart from the whatever we have THC, CO, NOx, CO2, particulate matter, there are several other species also comes into the market. Sorry, comes into the engine exhaust like hydrocarbons. Here we consider as the total hydrocarbons, but here there is individual hydrocarbons like formaldehyde, benzene, aldehyde, SO2, methane, pH, polyaromatic hydrocarbons. So these are very small in quantities, but slowly it is establishing slowly that even though their quantities, they are in small in quantities, but their effectiveness on the human health or the environment is very high. And therefore, what is happening slowly that some of the unregulated emissions are transferred from this table to the regulated emissions. Okay, CO2 here, some of the CO2 is somewhere in countries regulated and somewhere is unregulated. SO2, SOx like NOx is older way time or previously where the fuel contained a lot of sulfur. There the SOx emissions was also a very high and it was a concern. But nowadays, when we have a lot of emission standard, we have very strict emission standards, and for that, the fuel quality is also very high. The sulfur content in the fuel is very, very less. Let me tell you, just give you the figure that if you consider in around 2000 times, maybe at that time, the sulfur content on the fuel was around more than 1000 or 1500 ppm. Okay. Nowadays, when we have Bharat 6 norms, where here the sulfur content in the fuel is almost like 10 ppm. So now you can imagine from more than 1000 ppm has been reduced to the 10 ppm. Reducing the sulfur in the fuel content it requires a lot of technological development in the refinery system. So nowadays, the as far as the SOx or oxides of the sulfur is not a matter of concern because the sulfur content in the fuel itself is almost is nothing. Methane is another important things because in India or all over the world, CNG is the one of the main alternative fuels, and that is mainly methane. Any slip of the methane from the combustion is going to be really hazardous. So methane is also should fall on the category of regulated emission. Okay, so as far as the automotive company is concerned, they don't give too much attention on the unregulated emissions because handling the emissions, it puts a lot of burden on the automotive manufacturers. They only concerned about the regulated emissions and they try to fulfill these emissions should not be more than the whatever the government has put. But as far as the researcher or you or us concerned, we have to give the equal importance on the regulated emissions and the unregulated emissions because tomorrow some of these unregulated emissions is going to be transferred from these slides to the here. Okay, so these are the regulated, unregulated emissions. And yeah, it is well proven that this emissions that is coming out from the our vehicle is affecting the human health in several ways and as well as the environment also. So that is well medically it is well proven that. I still remember when I did my PhD from the IIT Kanpur, and then Kanpur city was one of the most, I don't know, most pollutant I should say or not. I'm telling the story of something around 2008 or 7 like that. So once you are going out from the campus in the market where we need to buy it from for anything research purpose, at least on that day you are not going to anything. Once you come back, you have some kind of the what is called um, irritation in the eyes, in your lung, everything. That is the practical feeling. But with the when the CNG comes and then the further limitations comes on the emissions, nowadays it is breathable. So that is the very it's really what I'm trying to say, that the emissions is really very bad way it has affected, and we need to take care. So what is the emissions regulation? Okay, first of all, okay, here, do you have any questions up to here? Anything, questions? No? Okay, that's fine. Now, let us suppose we have some kind of legislation that HC should not be more than 0.5 gram per kilometer. Okay. Now I'm giving one value that car should not emit this much gram per kilometer. Now the question is, how can I put one quantity, only one quantity? Because till now we have studied that once you change the operating condition of the engine, then the performance as well as the emissions is also going to be changed. So if I'm putting one value, then there is certain question comes into the mind that under what conditions we are saying that the emissions should not be, or particular species should not be more than this much gram of per kilometer or per kilowatt hour. Is it that operating condition is representing the overall operating condition of the engine? How I'm going to choose that a particular operating condition and say that the emissions should be tested only on this operating condition of the engine? So that has to be very clear right now. So it is not like that the whatever the quantity has been specified for the particular species, it is corresponds to a particular operating condition of the engine. It is not like that. It is not like that emissions has to be tested. Let's suppose 2000 RPM and 50% load on the engine, and then if your car or your two-wheeler is satisfied, and then it's okay. It is not like that. There are several ways to do that, and that represents the overall operating conditions of the engine. For that, what we have a different emission test cycles. Okay, there are transient emission test cycles, a static steady state emission test. There's different cycles. Even transient conditions, we have a different cycles. Cycle is, it means the speed, okay, is defined over the time, that how the speed has to be varied. And it is a very short spent time, and your cycle or the driving cycle, that is called driving cycle, is actually representing the the most of the transient driving conditions on the city or in the highway. Each country has their own driving cycle because each country has a different way to drive it. The peoples have a different nature to drive the car or vehicle, whatever. They have a different roads. They have a different traffic rules. Accordingly, the government has to find it out the driving cycles that is representing the most of the nature of the driving um, characteristics of most of the people. So there we have a particular driving cycle on which your car is going to be run in the laboratory on a specific dynamometer. In the class, we have discussed about hydraulic dynamometer, eddy current dynamometer, AC dynamometer. At that time itself, I also termed one dynamometer that is called chassis dynamometer. Chassis dynamometer. This chassis dynamometer is used to do the emission testings or the performance of the vehicle. Wherever other three dynamometer, whatever we have discussed in the class, it is used for the engine only. So the driving engine of your vehicle has to be run on the specified cycles on the chassis dynamometer, because you are not going to run the vehicle over on the highway, because then how you are going to take all sort of the accessories, emissions, regulations, and all sort of the things. Your test has to be done in a very specified conditions where you have to just specify that what is the coolant temperature, what is the lube oil temperature, what is the inlet air temperature, what is the specific humidity of the air. So what I'm saying, in standardized conditions, we have to do the testings on a specified driving cycles, and then we need to measure the emissions transient condition, transient way, and then we need to put some kind of the weightage and find it out one particular values. And that is what values is should not more than the whatever the as per the rules and regulations. That is called your what is called vehicle emissions. In static conditions, there are different cycles. Let's one of the example is 13 mode cycle. OK, 13 mode cycle. It means in it is a there are 13 operating conditions are specified. Your engine has to be run for idling condition, no load for certain period of the time. After that, engine has to go 50% load, engine speed, and 20% load in such way. OK, it's not I'm saying the correct sequence, but there are 13 operating conditions has been specified, and there is limitations also, time limitations, that all these 13 operating conditions has to be completed within the time, and at each operating conditions your vehicle should run at this specific time. 13 mode cycle that is called. So, and at each mode there is a certain weightage. So your vehicle should run on these 13 operating condition of the engine as per the within the times, and then measure the emissions and then multiply with the weighing factor, and then do the summations of all the emissions into the weighing factor for all 13 operating conditions, and you will get one single values. That is one of the way also. So what I'm saying, that there we have a specific way to do the testing for the emissions and then get one values, and that value should not be more than that limited particular values. OK, so here you can see I have given some units in gram per kilometer or even gram per kilowatt hour. OK, gram per kilometer is generally is termed use the unit for the cars, And then gram per kilowatt hour, it is used for the heavy duty vehicles, or even gram per kilowatt hour is used when we tested the emissions only for the engine. If the car if we are doing the testing for the vehicles, okay, then it is a car, then we term it as a gram per kilowatt hour. But if we are using only for the engine, then in that conditions we can use the unit gram per kilowatt hour. But gram per kilowatt hour is also used for the heavy duty cycles. Emission standards is becoming more and more stringent over the time. Okay, stringent in terms of the quantity, it is going to be lowered over the time again and again. But one thing we need to also think about that number of vehicles is also increasing over the time. Populations of the vehicle is increasing rapidly, and so and then we are trying to reduce the emission. It's more and more emission standards is very stringent. Then what is happening? That is very important to analyze, that since the number of vehicles is increasing, even though the emissions are going to be stringent over the time, what is the effectively we are able to reduce the emissions or not? That is one of the very continuous issue that needs to be find it out. As I told, most strict emissions legislations are in California. It is almost considered like air is going in and air is going out. There is a sad part that some part of the world is still we don't have the emissions legislation. But being the responsible country, I think most of the country have their own emission standards. How much stringent that emission standards is the question of debate, but that is the what way. So these are the emission standards. Okay, so this is the your his story of the Indian standards. We have emission standards that we called Bharat stage. BS2, BS3, BS4, BS5, BS6. As the number is increasing from BS1 and 1 and 2 to 6, it means BS6 is more and more stringent compared to the Bharat 2 or Bharat 3 or Bharat 4. Similarly, the Europe has a emission norms. They call it Euro. Euro 1, Euro 2, Euro 3, Euro 4 or something like that. Most of we can say that European emission standards and our emission standards are very close. OK, but obviously there are some deviations or we have modified it so that it can suit for our driving conditions and in our environment. And as I told that we cannot put the emissions legislation in one go all over the India because that will put too much burden on the automotive company as well as the government to supply the standard kind of the fuel. So it has been applied in the phases manner. So even Bharat Stage 2, when or Bharat Stage 3 or Bharat Stage 4, it is not applied. It is not applied across the India in one go. First of all, it was applied in NCR and some metropolitan cities. OK, then the number of cities is going to be included more and more. And once it is matured from the automotive companies comfortable, government is comfortable, then it can go for the whole India. So Bharat Stage 2 was started from 2001 to 2005. Initially, it was only for the few cities, and then it was increases more cities, and then from 2005 onwards, it was OK for nationwide. Similarly, Bharat Stage 3, it was in 2010, it was for all over the India. Bharat Stage 4 was initially started from 2010 in fewer cities, and then it was introduced all over the country from 2014 or 14 onwards. 2006 was delayed little bit because of this corona, but what happens in 2001, where here we can see that we have skipped the 2005. Sorry, we have skipped the Bharat stage 5. From Bharat stage 4, we are now in Bharat stage 6. And from 2020, 2020, yes, April, we have now Bharat stage 6. Whenever you see the car in the campus, that is the best way to get it. You see that either on the glass, either the back side or the front side, or even on the body, it is written what kind of the emission standards your vehicle is fulfilling. It is BS6, BS4, like that. Okay. Now with this a story behind the emissions, now we will discuss some technical things, that why we have such kind of the emissions during the combustion, and we need to find it out. Obviously we are going to give the focus only on the air regulated emissions as of this course curriculum is concerned a little bit, and our ultimate aim is what? As the manufacturer or as the researcher or as the students, is to how to reduce the emissions as much as possible without compromising too much with the power output and the fuel consumption. Obviously, if you are going to play to reduce the emission, then you have to compromise with the performance and the fuel consumptions. Now, how much? It depends on your objective and how much you can tolerate. You cannot launch a car where you can say that our emissions is even much better than Bharat stage 6, but your engine power output or vehicle power output or the mileage is very poor. Nobody going to buy it. As a customer or as a buyer, most of the people, I would say, they're not going to too much interested at whether it is Bharat stage 6 or what. Okay, they consider that mileage kitna hoga, what is the fuel consumption. Okay, how fast if I press the accelerator then it can achieve 100 kilometers. What is that acceleration? Emissions for the customer or for the buyer is the second priority, but obviously it should be the equal importance being a responsible citizen. But it is not true. So therefore, I'm saying that you have to fix that how much you are going to compromise with the performance, or is it possible that without comparing or compromising with the performance can be reduce the emissions. There is also a very important thing that all of you should know, that when we are comparing two sort of technology, okay, or let us say right now there is a lot of debate is going on regarding the conventional automotive engine and the electric vehicle. Okay, there's a lot of debate. Our intention is not to go into the debate. What I'm trying to say, that somebody can say electrical vehicle is the zero emissions. Okay, or hydrogen fueled engine is a zero emissions. They just put the sticker zero emissions. Is it true? In what sense it is a zero emissions? Or I'm saying that my car is producing, or conventional combustion engine is producing this much gram per kilowatt hour. Is it true that it is only producing? What happens from in the processing of who is responsible, who is going to take the shoulder of the emissions that has been already emitted in the atmosphere during the manufacturing of the car, during the processing of the fuel, during the extracting of the crude oil, during the what is called end of the life of the car. Same thing is also applied for the another technology that is claiming that it is a zero emissions. Okay, what will happen when during the for the preparation of the what is called battery? Okay, what will happen once the battery life is over? How we are going to dispose it? Is it not going to emit it? So what I'm trying to say that when we have to compare the two different technology as far as the emissions is concerned, then we should not choose or take the intermediate stage and then compare the two different technology. We should do well to well analysis. From where we are extracting the fuel and then the wheel when it is running on the highway. The same thing is true for any sort of the technology. And then overall in a whole holistic manner, we can compare the two different technology and then we can say that yes, this is a good technology, a way of transportation means for as far as the emissions norms is concerned. Hydrogen. If you are using the electricity to produce the hydrogen and then you are running the car and then you are justifying that it is a zero emission. What is that? So we cannot pick intermediate stage for our convenience and then we can claim that my product is good. That is what we need to understand. Obviously, we have to divert our different sources of the transportation means. It is well fact that crude oil or conventional oil is limited in quantities. I'm not going to comment on it is going to be ended in this much year on that much year, because when I was a kid, then I was hearing the news that petrol and diesel is going to be finished within the 25 years. OK. Now, even though I'm at this stage, I'm hearing that the petrol and diesel is going to be finished in 40 years. So that is another debatable topics. But nobody, we have to accept it that it is a limited quantity. We need to extract it is very carefully. We need to find it out the alternative ways also for the transportation means so that the burden from the crude oil can be removed. For that, we need to find it out the alternative fuels. We need to go with the electric vehicles also, hydrogen fuel vehicles also. We need to divert. We cannot rely on a single parameters because transportation is almost what we can say it is the heart of our daily life. We cannot sustain without the transportation. So we need to find it out a different ways. OK, we need to diversify the dependence on the dependence for the transportations as much as possible without going into the too much on political discussions or the another kind of the discussions that this one is good or that one is the bad. So we have to give now the equal importance on the alternative fuels as well as the electric vehicles also. Very important, so that we can reduce the dependency on the crude oil. Okay. So now the another questions also comes into the mind that once you see the any industry, particularly the power plant, okay, or any kind of the industries, you just cross from there, you see that from their chimney, a lot of black smoke is coming out. You may ask that, and even the from the car vehicular emissions, it's a hard if your car is very in good conditions, it is hardly to see that smoke is coming out. Then the questions comes immediately in our mind that why we are so much concerned about the vehicular emissions and not we are giving too much as much as same kind of the importance from the industrial emissions. That is also a need to be think. You may say the vehicular emissions is where these emissions is coming out. It is coming out in the dense populations region. It is on almost on the earth surface. So immediately as soon as these things is coming out, the human health is going to be affected. As far as the industry is concerned, they have a long chimney. The exhaust even it is going to be dispersed in the atmosphere. Obviously, it is going to be no doubt it is going to be affected on the human health as well as the too much the global environment. And we can say that obviously industry has all on the they have also emissions regulations. It's not like that they have a free hand. They have also emissions regulations, but obviously it is not so stringent as it is a vehicular emission. Okay, so as far as the vehicular exhaust emissions is concerned, a spark ignition and diesel engine both have a same kind of the stories. It's really very difficult to give any good marks to one kind of the engine. But one thing is sure that diesel engine has a slightly difficult way to deal with the emissions because of their heterogeneity of the fuel lab combustions. But yes, both have almost the major source of the urban pollutions. In these slides, there are some range of the emissions has been given. Obviously, this range depends upon the kind of the vehicle, but we can say that it is a true for the your car, that the oxides of nitrogen that is come NO plus NO2 in the order of 500 to 1000 ppm parts per million. Carbon monoxide falls in the category of 1 to 2% or 200 gram per kg of the fuel. Total hydrocarbons, it is in the order of 3000 ppm. Same thing is true for the CI engine also. What is the most important thing that we need to think that CO, okay, carbon monoxide is not too much important for the diesel engine. Why? That you need to think about that. Similarly, as far as the SI engine is concerned, particulate emission in terms of the number is not a big problem if you are using the port fuel injection system. So that you please think about that. This two questions is open questions, and probably we are going to be answer after 2-3 classes. That CO emission is not too much concern for the SI engine. Sorry, CI engine, diesel engine, but we have to give a very importance on the SI engine. Similarly, particulate emission is very difficult for the CI engine, but it is not so much as difficult for the SI engine. Yes, it is, but not up to that limit. Okay, so this is the story as far as the emissions is concerned. We need to discuss a bit about what are the different sources of the emissions that is coming out from the exhaust, but where is the problem in the combustions, how we are going to, we need to know the root region that why the emissions is coming out. Once we know the regions, then we try to find it out or neutralize that regions to lower down the emissions. Okay, that we will cover it in the sorry, next class. Okay, thank you. Do you have any question?